Hi, this question appeared in JEE Advanced 2021 in its second paper, and the question is from the topic maxima and minima, basically differentiation. So here we are given two functions and we have to find out m1, n1, m2, n2. I'll explain what m1, m2, n1, n2 are in the later part of the video, but let us go ahead and solve this question. But before we go through the solution, I would strongly recommend all of you to pause this video at this moment and give this question a try. So it is basically a paragraph question. So we have to answer these two questions. So in order to not make this video lengthy, I have written down the information given in the question here. So let us go through it. So there is a function f1, domain and codomain are given, and similarly for f2. So f1 is this function, f2 is this function. M1 is number of local minima of f1 in this interval 0 to infinite, and n1 is number of local maxima in the same interval. Similarly for this function f2, m2 is number of local minima, n2 is number of local maxima in this particular interval. So let us go ahead. So in the first question we are asked to find out this value 2m1 plus 3n1 plus m1n1. So let us consider the first function f1 of x. Okay, f1 of x, this is f1 of x. F1 of x is equal to integral 0 to x pi. That means it is a product. So 21 t minus j whole power j dt. All right. Now to find out local minimum and local maximum, we have to differentiate this function. So differentiate this on both sides. F1 dash of x. So when you have to differentiate the integral, you have to use Leibniz rule. So first put the upper limit in place of t and take the derivative of upper limit, which is 1, and then put the lower limit and take derivative of lower limit. We have to subtract that. Derivative of lower limit is 0. So this is the differentiation. So let us expand this. F1 dash of x is equals to x minus 1 whole power 1, x minus 2 whole square, x minus 3 whole cube, x minus 4 whole power 4, and so on, into x minus 21 whole power 21. So to find the extreme points, f1 dash of x is equal to 0. That implies x will be 1, 2, 3, 4, 5, and so on, 20, 21. Now we can use wavy curve method to determine like which of these points will be local minimas and like which of them are local maxima. Okay, so we can use wavy curve method to do that classification. So here I already made the line with the roots of f1 dash of x. So 1 to 21. So like let us recall wavy curve method once. Whenever there is an odd degree, the wave will change the sign. So let us start from minus infinite. So from here, so it is going to x is equal to 1, but x is equal to 1 has odd degree. So for values less than 1, this will be negative. F1 dash of x will be negative. So we are starting from here. So when it touches 1, the degree of 1 is 1, which is an odd number. So it will change the sign. So it will go till 2. So but the degree of 2 is 2. So it will not change the sign. Next it will go till 3, but the degree of 3 is 3. So it will change the sign again at 3. So it will come from plus to minus. Similarly at 5 it will go up. 7 it will come down. 9 goes up. 11 comes down. 13 goes up. 15 comes down. 17 goes up. 19 comes down. 21 goes up. Alright. So this is plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus. You can check this. You can put any value between 1 and 3. You will get a positive value for f1 dash of x. Similarly, you can check for other values also. So this is the graph of, this is the behavior. This is the behavior of f1 dash of x. It will just tell you whether it is positive or negative. Alright. So f1 dash of x is slope. So when it goes from minus to plus, there will be a local minima at that point. If it goes from minus to plus, that means that particular point is local minima. And when it goes from plus to minus, that will be local maximum. So this is wavy curve method. So now let us denote. So here it is given local minima is denoted by m1, local maxima is denoted by n1. So this is a local minima m1, this is local maxima n1. Similarly, this is minima m1, this is n1. N1 has different values. Minimum, this is maximum, minimum, maximum, minimum, maximum, minimum. Yeah. So how many minimas are there? Number of values of m1 is 1, 2, 3, 4, 5, 6. Number of values of n1, so that will be 5. So there are 6 minimum values and 5 maximum values. So now let us go back to the question. So here m1 is equal to 6, n1 is equal to 5. So 2m1 is 12 plus 3n1 is 15 plus n1 is 30. So 30 and 15, 45 plus 12. So this answer is 57. Okay, let us check the answer. Yeah, it is 57. Now let us go ahead and solve the second part of this question. Okay, done. So to solve the second part, let us consider this function f2 of x. f2 of x is equals to 98 x minus 1 whole power 50 minus 600 x minus 1 whole power 50 minus 600 x minus 1 whole power 49 plus 2450 plus 2450. So similarly, to find minima and maxima of this function, point at which minima and maxima occurs, we have to find out the derivative. So this will be 98 times 50 into x minus 1 whole power 49 minus 600 times 49 into x minus 1 whole power 48, and the derivative of this part will be 0. So this is x minus 1 whole power 48 into, so 98 into 50 times x minus 1 minus 600 into 49. So this is 49 and this is 49 into 2. So this is basically 49 into 100. This is 49 into 600. So 49 into 100 is common, and x minus 1 whole power 48, and here 49 came out and 100 came out. So this will be x minus 1 minus here there will be 6. So this will be 49 times 100 times x minus 1 whole power 8 times x minus 7. Now again, let us follow the wavy curve method. Okay, let us draw it with a different color. So let us follow the wavy curve method again. So here the roots are, so when you set f2 dash of x is equal to 0, the roots will be 1 and 7. So there is one root here which is 1 and one root which is 7. So if you put the value x less than 1, this will be positive but this will be negative. So our wave starts here, and x lies between, so it hits 1, but 1 has the even power, so the sign will not change. The sign will not change. So it will come like this, and it hits 7 now, but 7 has odd power, so sign will change. So it went from minus to plus. So if it goes from minus to plus, it is minimum, local minima, and when it goes from plus to minus, it will be local maxima. So here it goes from minus to plus, so that means this point is a minima. So m2 is minima, m2 is 1, and there are no maximas here, so n2 is 0. Now let us go back to the question. So m2 is 1, n2 is 0. If you put here 6m2 will be 6. This is 0 and this is 0 because n2 is 0. So the answer is 6. So the given answer is also 6. So if you like the content, if you like this video, please like the video, share and subscribe. Thank you.